Alright, so this video is going to be on finding the inverse of a matrix using determinants from chapter 3.3. So to give a little bit of background first, one of the important things for this is going to be Cramer's rule. If you remember that, this is the theorem for it right here. For any matrix A and for any B in R of n, the unique solution x to ax equals b has entries defined by xi equals the determinant of the matrix A, the ith row of that times b divided by the determinant of A. So that's just kind of background to get down to this stuff, and this stuff again is even more background. But basically this just helps us arrive at this point, which is the important part. So for the jth column of the inverse of I, we have that that's a vector x that satisfies ax equals e1. And then by Cramer's rule, we have this right here where the ijth entry of the inverse of I equals xi, which equals the determinant of IA times the identity matrix, the jth column of that, divided by the determinant of A. So going on from there, we'll note that the top, the numerator from this, is actually equal to just the cofactor ji. And then finally, going from there, we get to this, which is the main formula that we need to focus on. So the inverse of a matrix A is equal to 1 over the determinant of A times this, which we call the adjugate of A. So basically, it's just the set of all the cofactors of A, but you'll note that we switch the rows and the columns here. So like normal, if we didn't switch the rows and the columns, it would be C11, C21, and going down, but we basically switch these two entries. So that gets us to the theorem 8. This is the same thing as right here, just abbreviated with adjugate of A. And then a quick note for solving is, like I said, how we switch these, basically the row and the column. So if you want to solve the matrix, a lot of the times what you can do is just find the cofactor right here and then just swap it going over there. So now we're going to move on to an example.
Alright, so for this example, we want to find the inverse of the following matrix here. And so what we're going to want to do is we're going to find each of the 9 cofactors for each of the numbers in the matrix. And so once we find those, we want to make the adjugate matrix, which is basically just the transpose of those cofactors. So for example, you might have C12 here, and we want to put that in the C21 position in the adjugate matrix. And once we made that, we want to find the determinant, and we can also do this in a way that we can check our work at the same time by multiplying the adjugate of the matrix times the matrix itself, as shown here. And what we end up getting is the identity matrix times a constant. So then to find the inverse matrix, all we have to do using theorem 8, which we just showed you, is we just take 1 over that constant that we found and multiply it by the adjugate matrix, and we have the inverse matrix.